Factoring by grouping. In this video, we have to discuss how to factor some polynomials with 4 terms by grouping method. And some polynomials because not all polynomials with 4 terms can be factored. Now, what is the idea? So let's go back to multiplication. So we know how to multiply polynomials. Now, the terms of the first polynomial will be distributed over the second polynomial. So x will go and multiply y plus 2, and positive 3 will go and multiply y plus 2. And now we distribute, we multiply. X times y is xy, x times 2, 2x, 3 times y, 3y, and 3 times 2 is 6. Okay? And from this multiplication, we check if we have like terms. So in this case, we do not have like terms. Okay? So we are done. So this is what we did in multiplication. Now, when we factor, we go backwards as we discussed to the other video. So from addition, we'll go into multiplication. So this is the factoring. The terms in a polynomials are linked together by addition. So we have to try now to factor this polynomial, which is xy plus 2x plus 3y plus 6. And if we factor, we'll find these two binomials. Okay? Now, how to use this method? By the name of the method, it's saying that we have to group. So what to group? Terms in the polynomial into 2 groups. Each group contains 2 terms, and they will give us the binomials. Now let's factor each group. So the common factor here is x and nothing else. So open the parentheses and write what is left after the factoring of the common factor. So it is left y and here 2. The first group is factored, and as you see, the work corresponds. Now, and here on the second group, 2 is the common factor because 3 is the common factor because 6 and 3 are divisible by 3. So 3 is the common factor, y is not present at both, open parentheses, here is left y, and 3, and here is left 2. 6 divided by 3, 2. After we factor each group, we check if the groups have the common factor, and yes, they have. So the common factor now is the binomial y plus 2. Open parentheses, and now write what is left from each group. From the first is left x, because this is outside, and from the second is left 3. That's it, done. So the polynomial, when we factor, is turned into multiplication. That's it, the addition into multiplication, and this is the job of factoring. Now let's go and discuss some more examples. Now we factor these 4 terms polynomials by grouping, okay? Now, the first thing that always we have to do when we start a factoring process, we have to check what is the greatest common factor. So we have to factor out, if we can, the GCF. And GCF is the common factor of all terms in the polynomial. So let's check. 24, 6, 56, and 7. So we do not have a common factor here. Do we have a common factor from A? No. So let's go and factor. 24 and 6 both can be divisible by 6, so 6 is the common factor. A is in common, so 6a is the common factor. So what is left now? 24 divided by 6, 4, a is outside, c. Plus 6 is outside, a is outside, d. So the first group is 6a times 4c plus d. Now let's go and factor the second group. 56 and 7 both are divisible by 7. So 7 is the common factor. And what else? B. Open parenthesis. What is left? 56 divided by 7 is 8. B is outside, C. 7 is outside, B is outside, D. Now check. If the groups have the same common factor, so 6A, 7B, no, and the binomial is not the same. Here we have 4C plus D, here we have 8C plus D, so stop. And the answer is this polynomial is unfactorable. We cannot factor. Why? Because even though we factor the groups, we cannot continue factoring because the groups do not have a common factor now in order to continue as we did here. Okay? So not always we are able to factor. Now let's go to the other example. Do I have a greatest common factor here? No. So let's go and start the grouping process. So group terms. And now I have to factor each group. Here I see x is in common. So x is the common factor. Open the parentheses. Write what is left. A from the first, B from the second. Done. Here y is in common. So y is the common factor. Open parentheses. Write what is left. And here is left A and B. Now check if the groups have the same common factor. Yes, they have. So after we factor the first group, we expect the other group to give us the same binomial. And when the second group gives us the same binomial, we continue. If we factor the same group and we have not a common factor for both groups, we stop. Okay? So particularly the binomial is different. So I have to continue, yes, because now the groups have a common factor. So let's factor it out, A plus B. Open parentheses. What is left from each group? X from the first and Y from the second. Done. If we multiply, we'll go back and find the polynomial. So not always we are able to factor a polynomial in 4 terms, but it doesn't matter. We are looking for those polynomials that we can factor by this method. Let's go to example 3. As always, I have to check if the groups have a common factor or not. So this polynomial, if the polynomial has a greatest common factor, they do not have a common factor, group, factor each group. So 15 and 10, both divisible by 5. 5 is the common factor. X to the second is the smallest exponent. So the common factor is 5x squared. Open parentheses. What is left? 15 divided by 5, 3. From 3x's to our outside, 1 is left. Minus 10 divided by 5, 2. X squared is completely outside. Close the parentheses, and this is done. So the first group is 5x squared times 3x minus 2. Now we expect the same binomial from the second group or this monomial. Okay, it doesn't matter. Just we expect a common factor. Now, let's see, 6 and 4, both divisible by 2, so 2 is the common factor. Open parentheses, what is left? 3. 6 divided by 2, 3x. Minus 4 divided by 2, 2. That's it, done. Check the groups. Do they have a common factor? Yes, they have. I have a common factor. So what is the common factor? 3x minus 2. Open parentheses. What is left from each group? 5x squared plus 2. Done. If I multiply, I go back and find the original polynomial. Now, before I continue, I want to discuss something. So, example 3 is factorable. Okay? So we work and we factor it. Now, why? Because we saw that these binomials in both groups were exactly the same, and this came from the original groups. And now, let's check. So we have 3x minus 2, 3x minus 2. So not all the others, but the signs that separate the terms is exactly the same. Okay? Because if this is positive, suppose that this is positive, and now here I will have a positive, and 3x minus 2 is not the same as 3x plus 2, so the groups do not have a common factor, so I am not able to factor it further, okay? And I say, since I cannot go to turn the addition into multiplication, this means I cannot factor, okay? Now, what we have to be careful when we group the terms, we have to check the signs that separate the terms. Are they the same? If they are the same, we continue the work. If they are not the same, we have to check, may we make this plus a minus? In this case, we cannot. Okay? So, we cannot continue to factor. Okay? But they were the same. For this reason, we got the same result and the same binomial, and we had a common factor for the groups. Also here, example 2 was factorable. So why we have the same binomial? And this came because those two signs were exactly the same. So those two signs were the same, and we have the same sign that separate the binomial, okay? And now, suppose that this was negative, a positive, a negative, this will result to a negative. So what does it mean? These two are not the same. A plus b is different from a minus b. So we can stop and we say that this is unfactorable. So, in other words, we have to check the signs that separate terms in the group. And if they are not the same, we ask ourselves, can we make them the same? Okay, now let's see this in the example. Let's fix this because they were plus. Okay. Now let's go to example 4, and we'll see this through this example. Now, check for the GCF, no GCF here, group. Check the signs that separates term in the group. Are they the same? This is plus, this is minus, they are not the same, but it is okay. Why? Because I can make this plus. How? Since both terms in the group have a common negative sign, I can factor it out, and by factoring out negative sign, which is a common factor, -1, this will be left to a plus. And this will be left also to a plus. So, yes, I can do it. So let me continue factoring. What is the common factor here? Only x. Okay, open parenthesis. X, because x is the smallest exponent. So what is left now? 3. From 2x's, 1x is outside, 1x is left, plus 4. X is out, y is left, close, and we did for the first group, we factor it x times 3x plus 4y. And now we are expecting the same binomial or the monomial from this second group. Now, what is common in the second group? Only the negative sign, nothing else. So let's factor it out. Really, we are factoring -1, but we don't write -1. Okay? Let me open parentheses, write what is left, 3x plus 4y. So these terms are both positive because the common negative sign is in front, okay? Now, do I have a common factor? Of course, yes, because I worked for this. Okay? I was thinking during the work. I expected this. So the common factor is 3x plus 4y, open parentheses, and write what is left from the first group, x from the second negative 1. That's it. Done. If you multiply, you get the original polynomial back. Now let's go to the example 5th. Do they have a common factor, all the terms? No. Let me group. And now let me check. So the groups are separated by different signs. You see? The terms in the group are separated by different signs. 1 minus, 1 plus. Can I make this plus a minus? Yes. How? Because when I look at the first term of the group, it is a negative term. Now, I know that a positive is a multiplication of two negatives, so I will write this positive 6 as negative 1 times negative 6, or the negative of negative 6, it doesn't matter. So, if I turn a plus into 2 minus in front of a number, I know that this is a positive 1, okay? So let me substitute now this positive 6 with this. I can continue to factor the first group, but I will prefer not right now. I like to factor in the same time both groups. So let me rewrite the first group, and now let me fix this positive 6 as a minus and negative 6. Okay, and now the signs that separates the groups are exactly the same. And I'm going to factor each group. So here I have x, a common factor. I write 3. From 3x's, 1 is outside, x squared is left, minus 2, x is outside, close. So the first group is factored. Check. If you multiply, you get back the first group. Now, I have to factor the common negative sign outside, which is a factor, negative 1. Now, 9 and 6, both are divisible by 3. So x is not present. Negative 3 is a common factor. Open parenthesis. What is left now? 9 divided by 3 is 3 because the sign is out. X squared. Minus a negative sign is out. 6 divided by 3, 2. Or just negative 6 divided by negative 3 is okay, no, sorry. So 6 divided by 3 is 2. Okay, that's it. So you can make this mistake, okay, but don't mention it for right now. So x minus 2x. Now the groups have the same common factor, which is a binomial. Okay, so let's factor it out. 3x squared minus 2 is the common factor. And now what is left? X from the first group and negative 3 from the second group. Done. Now if you multiply these binomials, you will get back the trinomial. Now let me mention the mistake. So why we make this positive two negatives? Because we need to factor one negative sign and to be left with a negative in order both groups to be separated by the same sign. Okay, now when you think, okay, what is the common factor of negative 9 and negative 6? It is negative 3. Okay, and you are correct. But if you think separately, as usually we do, okay, I see the students in their work, so the common negative sign is out. No more discussion. And when you write down what is left, now you have only the symbol to work, not the sign. The sign is gone. Really, it is negative 1. Okay? So 9 divided by 3 is 3, and 6 divided by 3 is 2. Don't think negative 6 divided by negative 3, because you will make this positive, and our work went for nothing. Okay? So just keep in this mind. It's better to avoid this mistake to say negative 9 divided by negative 3. Negative 6 divided by negative 3, which will give you positives here. Okay? So first, factor out the negative sign and then think about the symbols. Because this is the original idea, to factor out a common negative signs, okay? Follow your ideas and you never will be wrong. Now let's go to example 6. So suppose that I will check for GCF, okay, and now I see that GCF is there present A. A is the only common factor for all terms. But suppose that I didn't see it, okay? And I'm continuing to continue and factor by grouping, okay? And sometimes students forget that they have to factor GCF first. So it is not a great mistake. We can fix this during the work. Now let's group. Let's check the signs that separates the group are okay. Okay, no headache during the work. So let's go and factor each group. 35, 42, both divisible by 7. 7 is the common factor. A is the common factor. So 7A for the first group is the common factor. Let's write what is left. 35 divided by 7 is 5. A is outside, plus 42 divided by 7 is 6. A is outside, C. So we are expecting a monomial in common or a binomial in common with the second group. Let's continue, factor the second group. Plus 18 divided by 5, both is divisible by 3. A is in common, D is in common. So 3AD is the common factor, open parenthesis, and now let's write what is left. 18 divided by 3 is 6, A is outside, D is outside, C. 15 divide by 3 is 5. A is outside, D is outside, that's it. Now check. Check both groups. So what they have in common? They have a binomial in common. So even though the order here is different, they are the same binomial. Why? We have a positive 5, a positive 5. We have a positive 6c, a positive 6c. So you can read 5 plus 6c or 6c plus 5 is the same. So they have a binomial in common. And what else? They have also a from the monomials. Okay? So now we have from monomials, we have a in common and binomials in common also. So the common factor from both groups is A times 5 plus 6c, or you can write 6c plus 5, doesn't matter. And now open parenthesis to write what is left. So again, we have A in common and 5 plus 6c. So A is outside. 5 plus 6c is outside. From the first group is left only 7. And from the second is left 3D. Because A is outside, 5 plus 6c is outside, and done. Okay? In this case, a four terms polynomial is factored in 3 factors. Okay? We have the greatest common factor, which was A, present at all. We can factor this in the beginning. This is GCF is A. So the greatest common factor and a common binomial. That's it. This binomial came from grouping. This came from factoring GCF. Done. This was the video about factoring by grouping. I hope you to use this to do your homework. Check your email because our homework will be there, or check your phone, the text message. And now I want to say thank you to you that you are listening to me, and see you on the next video when we'll discuss how to factor a trinomial. That's it. Have a good day and be safe.